Let me give you the setup, and I just want to change things up a little bit before you start. So it says, when you were 12, your father decided to start saving for your college education. He started by placing, so what they're not showing here is the first thing he did was he placed one coin on the table next to the board. So one coin. And then every month, so then after 1 month, he doubled the previous amount and put it, that first time he put 2 coins in the corner. Then every month after that, he doubled what he put in the previous square in the new square. So here in the second square, he put 2 times that, or 4. And then he doubles again. Every month doubling, like that. So I want you to start with, here's the order. Don't start yet, but I'm just going to tell you, and then I'm going to give you something to think about. So don't start yet, but here's what you're going to do once I give you the go-ahead. You're going to do the work on the table first in 1C, then go back and do A and B, and then and then you're going to work on page 136. As you're doing all of this, the whole point of all of this is to think about, we're setting the stage for this module, which is exponential functions or exponential growth. Okay, and it's my experience that when people hear exponential growth, what they think is just really fast growth, right? It's growing exponentially, okay? Which may be true, but in some cases. But we want to be a lot more precise about what exactly is exponential growth. So this first worksheet is really about trying to get you to come to start seeing precisely what is exponential growth about, or what characterizes this type of growth. What is the mathematical characterization? So what characterizes this kind of growth? And we want something mathematical, not something like, oh, it's just really fast growth. Okay, that's kind of the layman's way of talking about exponential growth. You say, oh, it grew exponentially. But we want to be precisely mathematical about what does it exactly mean when we talk about exponential growth. So the purpose of this worksheet is to kind of help you to see that as you work through these questions. So go slow, think about it, keep this in mind as you work, and do it in this order. And I'll just keep lapping around, and just catch me if you have questions. Okay? But we have plenty of time. You don't need to rush through this. So.
What about the changing of the dots? Do they just want the fifth, sixth?
Oh, just leave that row blank. They're just saying that you skip a few, you're skipping a bunch.
Okay.
So there's nothing in that row. Yeah, there's nothing in that row. Okay, you're free to talk, work together. Last chance to turn in homework. Are there any more? Do now, not at the end of class. Okay, in case you came in late, I need to see Hernandez and Staggers after class. Hernandez and Staggers. Blue shirt. Blue shirt. Sorry. Okay, we don't want to write 64 twos, but we want to show this product notation. So we can do what they did here, which is, okay, we got to have a 2 times 2. And then dot 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 means keep going like that until you get to the last 2, but then you have to specify how many there are. 64 twos. So that's a way to get the same kind of flavor of it, the spirit of multiplying 64 twos together. But even this, it took me 20 seconds to write that out. So that's what exponents are for. It's the same as what? So exponents are about taking a number and doing what to it? Multiplying, right? So exponents are just a shorthand notation for multiplication of the same number over and over again. Okay? And so then you were to come up with a function for the nth square. So that's like making another row down here, the nth square. So how many 2's would be multiplied together on the nth square? N, right? So we had n 2's. And how can we express that as a number of pennies with an exponent? 2 to the n. 2 to the n, okay? So what's the input of the function? What's the input of the function? And what square we're on. So what goes into the function is the square that you're on. And what's the output of the function?
Number of pennies.
Number of pennies. So our input is the square number, we're representing by n, and the output is number of pennies. And so what's the rule on n that gives us the number of pennies? 2 to the n, right? Most of us nailed that, okay? Most of us got that. So where it got a little different was they said, all right, so now Dad starts with 3 pennies off the board, and then for the corner, he does what? Doubles it, and then continues to double. So let's write that out. I'll do this in blue, okay? So in blue is this new situation for, what is it, 4a? So 3 pennies off the board. What would the product notation be for how many in the first square? Oh no, before I do that, sorry. Hold that thought. Okay. So what we want to talk about is what is characterizing the growth of the pennies? This is the whole point. Looking at how the pennies are growing as we go from square to square. What characterizes that growth? What is that? How could you describe what's happening that makes the pennies grow?
It's doubling each square.
Okay, doubling each square. So what operation is that? Doubling. What operation is that? Doubling. It's not squaring.
Is that factorial?
Simpler than that. What are we doing to get the next square? Multiplying by 2. Multiplying by 2. Am I multiplying the output or the input by 2? Am I multiplying an output by 2 or am I multiplying the input by 2? Ooh, I stumped you there.
Neither.
No, it's one of the two. Am I multiplying output values by 2 or input values? Okay, what's the input again? What's the quantity? Square number. Square number. What's the output? Number of pennies. Am I multiplying the square number by 2 or the number of pennies by 2? Number of pennies, the output. And when I multiply the output by 2, do I get an input or do I get an output? Which output do I get? The next one. Okay? This is how exponential functions work. Which operation is it based on? Multiplication. Is it multiplication on output or input? You're multiplying an output to get the next output. You see? So output is number of pennies. To get the next number of pennies, we keep multiplying by 2. Does the multiplier change? No. And that's convenient, right? We've just got one multiplier. That same multiplier always gives us the next output.
So in
Okay?
theory, n is the number of times you put it into the machine.
N is the square number. So starting from the original square, it's how many times you multiplied by 2. Yeah. So yeah, I think what you said was right. Okay, so this number, this multiplier that doesn't change, which is really nice and convenient, we get the same multiplier every time, is called the growth factor. And exponential growth is about what? Which operation? Right, multiplying. Repeated multiplication by the growth factor. Is it multiplication on the input or on the output? To get a new output, the next output. It's multiplication on some current value of output. It's the same growth factor. It will always give you the next output. If you were to advance the input by 1. Okay? If you were to advance the input by 1, multiplying by the growth factor gives you the next output. So let's look at that 4a. I'll do 4a in blue. Okay? So 3 off the table, or on the table. In the first square, product notation, how much do we have? Product notation. So 3 off the board. We're going to take that 3 and do what? Times 2. Second square. Times 3 or 2? 2. What happens to the 3? We just get one of them, right? So the 3 will not play into the exponential notation because we always just have one of them. So on the first exponential notation, 3 times what? How many 2's? 1. Second square. Right? Third square. How many times 2? Okay, 14th square. What would I do to that value right there? What would I do to that value right there to get the number of pennies in the 15th square? What would I do to that value right there to get the number of pennies in the 15th square? Multiply by 2. What's the growth factor for the new situation? Is it 3? Still 2. We're still multiplying by 2 to get the next value of what? Output, to get the next output. So maybe we call that G. What's the rule? So, and the last problem on that page, so, excuse me. So, why is it that the growth factor stayed at 2 and didn't change to 3? Because we're still doing what? Doubling. It's still doubling, and that's multiplying by 2 every time. So, in both those cases, the growth factor is 2. Okay, questions on those two examples? Now, the last one on that page was at 4C. 4C. So just take a moment just take 30 seconds there and see if you can do 4C. Does it say 7 off the board, then triple? Is that right? So in the first square, product notation would be 7 times tripling, right? 3. Then 7 times 3 times 3. What about the fifth square? Every time we advance a square, how do we get the new number of pennies? Which is so mathematically, what is that? How do we get the next number of pennies? Multiply by? What's the growth factor? And we multiply 3 by the input to get the corresponding output. Is that right? We multiply 3 by the input to get the corresponding output. Right? No. We multiply 3 by some value of output, and that gives us the next output. All right? See, output is the value of the function. That's what's growing, right? So the growth factor acts on the output to give you the next output. Okay, so this function, call it h. H of n is? We always have 1, 7. However many squares we go, so however many squares we go, that's how many times we end up multiplying by 3. However many squares we go, if we go n squares, we've multiplied by 3 times. We multiply by 3 n times. You see? Any questions for the quiz? Yeah? You can do it. You do it. You can do it. Okay, ready to go? Okay, get top hat ready. We're going to do them one at a time this time.